So guys, we just made a simple circuit. There we have the variable resistor, an LED, a DC voltage source, and then we connected a voltage meter over here with across this resistor. We are using the variable resistor and current over here. Now if you go through the presentation, you can see that Ohm law is V equal to IR. Since we will be changing the resistance to verify it, so we just did some algebra. R is equal to V over I. This means that if resistance increases, the voltage will also increase, and if resistance increases, the current will decrease, because it's inversely proportional to current and directly proportional to voltage. Now let's run the simulation and verify this. Okay, the simulation is on. Now what I do is that I change the value of the resistance. So the resistance is set to 100. You can see that our resistance is set to 74.5%, and at this stage, let me zoom in. At this stage, you can see that the voltage is 4.35 and the current is 5.85 microampere. I increase the resistance to 90%. Now see, the voltage has increased to 4.363 and current has decreased to 482 from 565 or something. If I increase it further, the voltage is now 4.36 and current is now 4.36. So the voltage is at maximum, the current has decreased because it's a 10K resistance. Now if I decrease the resistance, I bring it to 45C, you can see that once I am decreasing the resistance, the voltage is decreasing. It now 4.35, now 4.34, while the current is increasing. It is now 1.3 milliampere. Now if I decrease it further, the current is now 3.1 milliampere. If I decrease it further, now the current is at maximum value. So the LED is brightest and the voltage is in the inverse proportion. Now see, if I increase the resistance, the voltage is increasing from 4.32 to it goes up to 4.36 and the current keeps on decreasing. Now it is at 78.5% of 10K resistor. The current is at 555 microampere and the voltage is at 4.36 volt. If I increase it further, the voltage increases to 4.366 and current decreases to 4.36 microampere, and LED is at minimum brightness because the current has decreased so much. If I decrease the resistance, see, the opposite happens. If I increase it, see, the voltage is increasing and the current is decreasing. So this verifies this equation, that is R is equal to V over I. If resistance increases, the voltage increases and the current decreases, and this in turn verifies the Ohm's law that our circuit is following. Guys, welcome to learning microcontrollers. In this video, I will be showing you something called Ohm's law, V equal to IR. We all are familiar with this word called Ohm and Ohm's law, and we know this is the basics of our electronics and electrical engineering. So in this video, I will tell you how this works, some basic introduction and some basic description, and then I will take you to a simulation on which I will demonstrate to you how V equal to IR works. So it will be a simple lecture for you to give you some bit of understanding of the Ohm's law using a simulation. So guys, this is what an Ohm law is. V equal to IR. V is the voltage, I is the current, R is the resistance. This means that V is equal to IR. It means that V is directly proportional to I. This means if voltage increases, the current will also increase, because proportional to I means voltage increases, the current will increase. Similarly, with the R, V is also proportional to R. So this means that if the voltage increases, the resistance will also increase, or the increase in resistance will cause the increase in voltage. Simple. Now guys, the thing is, V equal to IR, we will be using an example. I will be making a simple circuit on the simulator, and in that we will be varying the resistance to see what impact it brings on the voltage and current. If it brings the same impact as per our expectation, as per this equation, it means it is verified. If it is not, then it is not verified. So if we do some simple algebra, I keep the V there, I take the I over there, here it is multiplying, there it is dividing, so V over I equal to R, or R is equal to V by I. So this means that R is equal to V over I, that R is directly proportional to V. This means if resistance increases, the voltage will also increase. And for the current, it is inversely proportional to I. This means if resistance increases, the current will also decrease. So current will not increase, current will decrease, and the voltage will increase. Now we verify this on our simulation. So I will be using an online free tool, Multisim Live. You can use the Proteus as well. We will just be making a very simple series circuit. So let's go to our multi-sim live. Go to your, so this is our multi-sim live. Click on the first link. Okay, you have to be logged in. Click on login, write your email. I have a lecture on this, an introductory lecture. You can go through that if you have not understood how to log in and stuff. It's a free software, online tool. No need to worry about paying for it. Okay, now this create button appears after you are logged in. Click on create button. There we go. So we will just be making a simple circuit having an LED and a resistor. That's all we will have here. Okay, so this is our voltage and these are our voltage sources. Select a DC voltage source, place it. Now we need a resistor. Since we are going to change the resistance, that's why we did some algebra to write it R is equal to V over I. If the resistance increases, the voltage is supposed to increase and current is supposed to decrease. So there we go. The variable resistor, I rotate it. Okay, we just make it this way. Okay, it seems fine. There we go. Now let's place an LED. This will be the LED over here. Connect them. The negative cathode of the LED goes to your voltage source and your voltage source will go to one end of your resistor, and from the other end this will go to the LED. We will leave one end empty because we are using it as a variable resistor only, not as a potentiometer. So this will be the circuit. Now let's connect the meters. So we will be measuring voltage across the resistor. This resistor, the negative, to be connected here. Okay, this will show opposite. So we connect the positive at the positive end like here, and negative here. That will be fine. Okay, and now the current, for the current, this is the ammeter. We have the ammeter here. We connect it after the resistor like this. Okay, now let's run the simulation. Okay, simulation is on. The variable resistor value is set to 10K and it is at 50% position. At 50% position, so at 50% position you can see that the current is 869.70 microampere and the voltage is 4.34. So I increase the resistance. I make the resistance at 70% of 10K. Now the voltage is 4.35 and current has decreased to 613. I increase it further. The voltage is increasing and the current is decreasing. See, if I move it, I lower the resistance. I go to, like, I want to lower down the resistance again. Okay, let me place it where you can see both. Okay, now I lower down the resistors, value of the resistance. Okay, now the resistance is supposed at 0.00. You can see the voltage is maximum. The LED is now brightest because, as I told you, if the resistance decreases, the voltage also decreases and the current increases. See, the current has increased, so the LED is brightest. I move the resistor forward. Now see, the voltage is increasing but the current is decreasing. See, now it is 4.43. now it is decreasing 2 milliampere. It's around 1.7 milliampere and the voltage is 4.3 volt. I move it further. Now voltage is 4.34 and the current has decreased to 1 milliampere. Now I go to 80%. Now voltage is 4.36 and the current is now 548 microampere. Now you can see that increasing the resistor increases the voltage and decreases the current. Now if we go back to our simulation, there you can see that R is equal to V over I. This means that resistance increases, the voltage will also increase. This means if resistance increases, the current will also decrease. The current will decrease and the resistance will increase. So guys, this is it. This is how I wanted to show you how the Ohm's law works. If you guys have any questions, you may ask. We'll see you in the next lecture. Goodbye until then.